This is a worked example for a z-test to compare the difference between two proportions. We begin with the following example. It states that a food researcher for LA County wishes to test a claim that there is no difference in the proportion of people who enjoy sushi, we'll say who enjoy eating sushi, and the proportion of people who enjoy eating ramen. Sample data has been collected below. Test the claim using alpha 0.01. So we collect a sample of 45 people and 15 of them enjoy eating sushi. We collect a sample that's independent of the 45, meaning there's nothing common to these two samples. And so there's 55 people. Of the 55, 12 enjoy eating ramen. Step one is we have to identify the claim and determine H naught and H sub 1. We'll let P sub 1 represent the population proportion of people who prefer eating sushi. P sub 2 is the population proportion of people who prefer eating ramen. The claim is that there's no difference between the proportions. So it's stating that P sub 1 equals P sub 2. That's our claim. That's an H naught statement. The opposite statement of P sub 1 equal to P sub 2 is that they are not equal. That's an H sub 1 statement. We draw the normal distribution. Since H sub 1 has a not equal to sign, it's a two-tailed test. We then look up the critical values in table E or F. In this case, we'll use table F. So let me just refresh the memory on the alpha is 0.01. Remember, the two tail areas combined is equal to this alpha, 0.01. And if we use table F to look up the critical values, we look here in table F for two tails, 0.01, and we go all the way down to the Z value, 2.58. Thus we have a negative 2.58 as a left critical value, a positive 2.58 as a right critical value. Now we have to compute the sample proportions. So P hat sub 1 is 15 out of 45, which we round to 0.333. P hat sub 2 is 12 out of 55, which we round to 0.218. Next, we compute the weighted proportions. P bar is the sum of the two X values, 15 and 12, which adds up to 27. And then the sum of the sample sizes is 45 and 55, which is 100. So P bar is 0.27. We also have to compute Q bar. Q bar is 1 minus P bar. 1 minus 0.27 is 0.73. Now we plug everything into the test point. The test point is the difference in the sample proportions minus the difference in the population proportions divided by the square root of P bar times Q bar times the sum of the reciprocals of the sample sizes. So let's plug everything in. So if we recall, P hat sub 1 and P hat sub 2 are 0.333 and 0.218 respectively. We plug those values in. I like to leave out the difference of the population means because they are equal to 0. So instead of writing minus 0, I just leave it out because there's nothing there. P bar is 0.27. Q bar is 0.73. We have 1 over 45 plus 1 over 55. And when the computations are completed, we should end up with 1.29. Let's go ahead and work that out using a scientific calculator. So for the numerator, I type in 0.333 minus the second sample proportion is 0.218. Then I close the parentheses, divided by the square root, and I keep everything inside the radical, 0.27 times 0.73 times, and inside the radical I include parentheses, and I type 1 divided by 45 plus 1 divided by 55. Close the parentheses. After I input the formula for the test point, just hit enter, and then we could verify it is 1.29 if we round the two place values. 1.29. Now we make a decision regarding H naught. 1.29 falls in the non-critical region, thus we do not reject H naught, and we summarize the results. There is not enough evidence to reject the claim. Thanks for watching the video.